In this video, we're going to take a look at arc length. Now, before we jump into arc length, let's talk about circumference. This should be something we've talked about before, but let's just review real quick. Remember that circumference is a fancy word for saying the distance around the outside of a circle. So you could start, at this location here and, kind of measure the whole way around the circle, and that distance would be your circumference. And if this is our radius from the center to the edge, our circumference is equal to 2 pi r, or sometimes you'll see it as pi d because the diameter is equal to twice the radius. But for our purposes here, 2 pi r is going to work out just fine for us. Now, notice, this works well if we want the whole circle, but here's the question that arc length poses. What if I just want part of the circle? What if, say, I just want half the circle? How would I go ahead and solve that? Well, I would probably take 2 pi r and just multiply it by 1/2, right? Because I'm dealing with 1/2 of the circle. Okay, but what if, I'll leave this 2 pi r here, but what if I want a quarter of the circle? Or what if I want 45 degrees, okay? There's a way for us to solve that out. And if we're talking about degrees, you want to think about how many degrees do I have versus how many degrees are in a circle. So how many degrees are in a circle? Well, it's 360, right? So what we're going to do is just make a fraction of how much of the circle are we talking about times the arc length. So if I, in this case, say I want 45 degrees, well, it's 45 out of 360. That's the fraction of the circle. And then this is the length of the whole circle. So we take the fraction of the circle times the length of the whole circle, and that gets us arc length. So let me give you the formula here. Arc length is equal to angle over 360, so whatever angle we're talking about, times 2 pi r. Now, in this formula, normally we're going to plug in an angle and a radius, but we should be able to solve it if it has diameter. We could solve for the radius and then solve for that. Or if we're given the arc length, we can plug that in on the left side and then solve for either the radius or the angle given the other one. So let's go ahead and let's solve some basic problems here. All right. So notice this one. My formula is angle over 360 times 2 pi r. Okay? So if I want to find the distance, now don't get this confused with the measure, okay? Arc length is a distance. Arc measure is an angle. If we wanted the measure of angle of A to B, where we would put an M out in front if I wanted the measure, that would just be 60 degrees, right? Because central angles and their measures are the same. So don't get this confused with measures. This is a distance. So to find the distance, what I'm going to do is I'm just going to plug in here 60 over 360. Times 2 times pi times 18. Now, there's two ways to enter this answer. One way would be to leave it in terms of pi. So let me show you how to do that. What I'm going to do is I'm going to multiply 60 over 360 times 2 times 18. And I'm just going to leave the pi out of my calculator for the moment. So 60 over 360 times 2 times 18. And what I get is I actually get 6. So I get 6 and then pi, because I didn't multiply pi into my answer. So if they ask for your answer in terms of pi, what you're going to do is multiply all the numbers together except for pi. You're just going to leave pi on the side, and then your final answer will be that number times pi. Now, they might ask you for, say, an answer rounded to the nearest tenth, in which case we are going to multiply second and pi. Now, the pi button, if you're in something like Desmos, you can hit pi, that'll get you the pi symbol, or there is, if you hit second and hit your caret symbol, it's just above your division sign on your calculator, that would also get you pi, and in this case that would come out to 18.8, okay? If we round it to the nearest hundredth, then it would be 18.85. All right, let's take a look at another one here. Let's find the arc length for CD. So let's do a little bit of work before we move forward. Let's figure out my angle and my radius. If I find those two things out, I should be good to go. So my angle right here should be 90 degrees, right? So that's going to be a 90. And then this distance right here from the center to the edge is my radius. So if my diameter is 28, my radius would be 14, right? So this would be 90 over 360 times 2 times pi times 14. All right? And let's answer this in terms of pi, 90 over 360 times 2 times 14. So this would be equal to 7 pi. That works out nicely. A lot of times we like terms in terms of pi because then you don't end up having to do a whole lot of rounding or things, and it's a very nice pristine answer. But should I multiply 7 times pi, I would have gotten actually roughly 22.0, okay, if we were rounding to the nearest tenth there. All right, let's look at one or two more. All right, notice this one. We want to find the arc length of FG. Now, notice, we don't have the angle for FG. We do have this GH angle here, okay, or that angle, that measure right there, but we don't have the FG measure. So what I'm going to do is I'm going to use what I know about circles. I know that half the circle is 180, so the FH is a diameter. I'm going to subtract 45 out, and I get 135. So that is the angle we want to use. So do be on the lookout that sometimes they'll ask you for lengths that maybe you don't have the angle for, but you have to solve the angle for those measures so that you can use it in your formula. So 135 over 360 times 2 pi times 15. All right, and let's take a look. 135 over 360 times 2 times 15. I'm just going to leave this one in terms of pi. That would be 11.25 pi. All right. All right, so actually that was the last one. We do not have a worksheet on Classroom. So what I want you guys to do is do the assignment. This hopefully is not too hard, okay? The big idea here is that if we take the circumference and we multiply by the fraction of the circle that we're talking about, that's going to find us the arc length for that particular arc. But this wraps up our lesson on arc lengths.